Good morning, students. Right here, how to represent a vector. Right, we are going to resolve or we are going to represent that one. Right, to represent a vector of with the orthogonal unit vectors means how we write a vector with the orthogonal unit vectors. So for that, you know that this is a vector A which is resolve, or better we say split into the two different vectors, and that is ax vector and ay vector. Ax is toward the x-axis, is it right? And ay is toward the y-axis, which I have written here. It is now according to the law of parallelogram, we know that from a common points, both the vectors starting from the common points, and a is a diagonal of it in the parallelogram, then we can say a, the resultant, a is equal to ax plus ay. So this is under the resultant. I mean to say, better we say, according to the law of addition, we have written this. But here, ax and ay, if they are a vector, then the vector can be again written in the form of a vector has magnitude and direction. A vector has magnitude and direction. And let me write this here. So this is a representation of a vector. Is it right? एग्जाम्पल मैं दे देता हूँ. एग्जाम्पल जैसे कोई भी एक वेक्टर ए है, उसको लिखा गया है सपोज 3i प्लस 2j कैप. I have written in the 2D form. याद रखना है I और J में लिखा है. So this is a vector. So here 3 is the magnitude and 2 is also the magnitude, and definitely it is toward the x-axis and toward the y-axis. Is it clear? ये हो गया तुम्हारा वेक्टर का रिप्रेजेंटेशन. नाउ आई विल क्लियर दैट हाउ वी राइट द मैग्नीट्यूड ऑफ इट. अगर मेरे को इस वेक्टर मैग्नीट्यूड रिजल्टेंट का अगर मैग्नीट्यूड निकालना है, फॉर एग्जांपल ax, तो मैग्नीट्यूड क्या है तुम्हारा 3, इसका कितना है 2. सो इन सिमिलरली व्हाट इज द मैग्नीट्यूड ऑफ a? इज इट राइट? ओके, so find the magnitude. Now you can see, right, a vector also can be represented in this form of a cos I cap plus a sin j cap. Is it right? So in the equation number 3, we got it that a vector is what? Ax of I cap plus ay of j cap. You know this ax is definitely is a vector. So vector direction always indicated by the what? I cap. But this also can be, if angle theta is given, then I think I will write here it is a cos theta. Is it right? And here I will write definitely a sin theta. So that's why I have written here a cos theta, and this is what? A sin theta. And I have already informed you, even I will already teach you how we and why we write a cos and a sin here. It is now if I compare now squaring and adding the coefficients of the 4 and 3, because your target is to find the what? Your target is to find the magnitude. So magnitude is only possible with the help of the coefficient. So in the equation number 3, coefficient is ax and ay. So squaring and adding here, in the equation number 4, it is a cos and a sin. Squaring and adding, I got this. So this is the formula of what? Finding the magnitude. And similarly, when we are going to find out any angle, so suppose theta is the angle between the resultant and one of the vector, then here we know that कैसे इसको लिखा जाता है. If I'll form a right angle triangle, then you say perpendicular by base tan theta is equal to ay by what? Ax, because we know it is perpendicular by base. So ay by ax is the what? Formation. Is it right? Whereas we can write ax by what? ay also, but theta तुम्हारा इधर आ जाएगा then. Is it right? So keep it in mind. So important is the theta angle. Is it clear? So here in this situation I will write it is what? Ay by ax. Is it clear? Yes. So in this way we find the 2D. Let's see to find how it is 3D. Now we are going to represent a vector with the orthogonal unit vectors in the 3D. So for that, let me take this is x-axis, y-axis and z-axis, and this is a vector A. Is it right? Which is a part of the cuboid or cube of OA. Sorry, OQ. You can see this is a vector A, and whose components are AY, AX and AZ, which I have written here. AX, AY and AZ vectors are the components of the vector A. So is it right? So that's why we can write OA means what? OQ. Is it right? So definitely with the help of the additional vector we can say, Is it right? By law, you can write here, by law of what? Parallelogram. Is it right? By the law of parallelogram, we can say once again, this vector A is a diagonal part, and definitely AX and AY are from the common point. So that's why I've written here parallelogram. So look at here, OQ is definitely, it is OV, sorry, OA na, is a vector OQ. It is O, I have written here, it is what? OR. You can see this is also can be possible. OR, one of it, and OT. This is OT. Is it clear? But OT is nothing, it is AY. Is it right? And this OR. So once again, let me take the cases of OR. Here OR is again a vector which is again represented with the two vectors toward the AX and what? AY. So if it is the resultant of these two vectors, then OR is equal to OS. This is OS, and OV, and this is OV. So you can see OS is nothing, it is AX, and OV is what? AX. So I have written here. Now let me place this value of OR in the equation number 1. Sorry, equation number 1 or 2 same. So 1 or 2. So equation 2 can be written as this. Vector, this OA is A, and it is OR. OR is AX and AY, AX and AY, and AZ. Is it right? Sorry, this is also AZ. So in this way it forms AX plus AY plus AZ. And now this is also can be written in the form of with the orthogonal unit vectors, that is AX I cap plus AY Z cap plus AZ K cap. तो ये तो हो गया तुम्हारा वेक्टर लिखने का तरीका. We know this. Is it right? This is the way, and this is simple derivations of this one. Is it right? Sometimes in the school, some of the schools they give, or sometimes some of the school they doesn't give it, right? So if it is given, then you can solve it in this way. Is it clear? Now let me see how we represent a magnitude. Magnitude को कैसे लिखा जाता है इसमें? Is it right? So to write this magnitude, is it clear? To find this, we'll use this Pythagoras theorem. So you can see, अब ये Pythagoras देखने वाली है. So this is a vector. You can see, right? Definitely, this is a right angle triangle, right? You cannot deny that here the formation is a 90 degree. So if it is part is 90 degree, ये part तुम्हारा 90 है, देखो, है ना? Definitely ये तुम्हारा plane में है और ये perpendicular. So this is a part of 90 degree, and definitely this is a what? Hypotenuse. This is what? 90 degree. I can take either this is perpendicular or this is perpendicular. So whatever it is, I have written here OR and RQ square, Pythagoras, where RQ is parallel with Y. देखो जो पैरेलल होगा उसके साथ हम लोग सेम वेक्टर लिखेंगे, है ना? तो ये पैरेलल किसके साथ हो गया? पैरेलल तुम्हारा y के साथ पैरेलल हो गया. That's why I have written here AY square. But OR I don't know anything. Again let me consider this right angle triangle OVR. Here also again this is a 90 degree. So फिर से ये हो गया तुम्हारा hypotenuse. So here hypotenuse is OR square, and OV, this is what? OV, and this is what? RV or VR square. This is parallel with the AZ, and OV is parallel with the AX. So I have written here AX square plus AZ square. And now let me place this value here in the equation number 1, so that you will get this equation again, or this is, है ना? इसका सबसे बेस्ट एग्जांपल क्या है तुम्हारा? सपोज एक वेक्टर है तुम्हारा 3i cap plus 2j cap plus 5k cap. It is written. Now find the magnitude of this. तो मैग्नीट्यूड क्या होगा तुम्हारे पास? हमेशा कोफिशिएंट, बिकॉज हियर यू हैव रिटन ओनली द कोफिशिएंट्स. So 3 square 9 plus 2 square 4 and 25. In this way 29 and 8 is 38. In this way you can say 38 square under root of 38 is the answer. Is it right? 38 is the what? Square root of your answer. तो इस तरह से हम इसको रिप्रेजेंट कर सकते हैं. Is it clear? Okay.